Here is what you will learn in this lesson and what you'll be able to do after this lesson. You will be able to round any number to a specified number of decimal places. You will be able to round any number to a specified number of significant figures. And you will be able to estimate the answer to a calculation by rounding the number first, using any of the two rounding methods. Firstly, let's talk about what exactly approximation is. So, approximation means finding a value that is close to the exact answer, but it is simpler to use. An example of this might be your weight. Your weight when you step on a scale is not usually exactly what the scale shows. So the scale might show it to one decimal place. For example, me, I am 86 kilos. Yes, I'm a fat boy. But my actual weight is not 86 exactly, right? It might be like 86.1357 and so on, because I don't have a specific mass, which is 86. But when someone asks me what my weight is, do I give them this thing right here, this figure? No, I give them this figure, because I'm approximating that weight into a much more simpler weight that I can use. And that is because this very exact answer is not needed. It won't matter if I tell you I'm 86.1357, and it won't make a difference than if I tell you that I'm just 86 kilograms. That is why we approximate. And then the question comes, how do we approximate? How do we approximate? The rule that we use, I call it the look next door. And whether you are approximating to the nearest decimal or significant figure, the method look next door is the same. I'll give you the steps of what to do for this look next door method. Number one, you find the digit that you want to stop at. Obviously, this might be given, sometimes it's not given. For example, in my weight, if this was my exact weight, I wanted to stop after the second number, and so I did. But that's not it. After you find the digit that you want to stop at, which is the second digit in my weight example, then I look at the digit to the right of it, which is where the look next door comes in. So I'm looking at the next door digit. If that digit is 5 or more, I will round up the stop digit, the digit from step 1, the digit where I stopped at. And if the digit is less than 5, I will round down the stop digit. And these are the steps of approximation using the look next door method. Now we look at the two methods of approximation that we discussed in the objectives. The first one is rounding to decimal places. And this method focuses on the digits after the decimal point. So you know, if I get a number, like in my example, 86.1352, It's focused on only the numbers after it. So one of these would be your stop digits. If they say round this to the nearest 2 decimal places, then my second decimal place is my stop digit. In this example right here, my second decimal place is the number 3. So stop digit is 3. Then I will look next door. What is the number on the right? So the way I like to do it is I like to actually create my door. Look at the next number. Is it 5 or more? And yes, it's 5 or more because it's 5. And because it's 5 or more, we will round up that stop digit. Therefore, that 3 will become 4 because the number next door is 5. And therefore, if I'm told to round this number to the nearest 2 decimal places, what I will get from it is 86.14. Let us take a look at another example, 7.845. And you want to round this off to 1 decimal place. For that, we first have to identify our stop digit, which is the first number after the decimal point, which is 8 right here. So my stop digit is 8. And then what I have to do is look at the next number, the number next door. So for that, I'll draw my door and take a look at the number after it, which is 4 in this case. Since that number is below 5, we will have to round down our stop digit. Rounding down means we leave that stop digit number as it is. Remember, rounding up, we increase by 1. Rounding down, we leave it as it is. So that 8 will remain 8 because the number next door is 4. Therefore, my final approximation from 7.845 to 1 decimal place will just be 7.8. So remember, when you're rounding up, you will increase that stop digit. When you're rounding down, that stop digit stays the same. What about when you are told to round off to the nearest significant figure? The only difference that this has to the decimal point method is finding that stop digit. How do you find the stop digit? And for this, there are a few things that you need to understand their definition. Firstly, what are leading zeros? These are the zeros at the start of a number. And most of the times, these exist whenever the number is very small. So, for example, 0.005. These 3 zeros are known as the leading zeros, the zeros that are at the start of the number. And then let's take a look at what trailing zeros are. Trailing zeros are the zeros at the end of a whole number. So the zeros that are before the decimal point. For example, if we have the number 52,000, then these 3 zeros are known as the trailing zeros, the zeros at the end of this whole number. If we had a decimal here of 00, these are not trailing zeros. Now let me explain what significant figures are. These leading zeros are not significant. These trailing zeros, they may or may not be significant. Now let's move on to the method of rounding off to the nearest significant figure. The only important part being finding the stop digit, because the rest of the method stays the same. In order to find your stop digit, let's take an example for that. So my example being round 43.25 to 3 significant figures. And so I'll start off by counting my significant figure. I always start counting when I hit my first significant figure from the left. Remember, if I had leading zeros, those are not counted as significant figures. Therefore, I would count this digit as my first significant figure. We'll get to an example of that later. So here, 3 significant figures. We start from the left. My first significant figure is 4. Second significant figure is 3. Third significant figure is 2. This right here will be my stop digit. 2 is stop digit. Then the method stays the same. Look at the next door number, and if it is 5 or more, we will round up, and it will then become 43.3. Therefore, 43.25 rounded off to 3 significant figures would be 43.3. And as you can see, there are 3 significant figures here, the digits that are significant. For the next example, let us take a look at a case of the leading zeros. 0.00403, and we want to round this off to 2 significant figures. And for that, we'll have to count those 2 significant figures. Remember, leading zeros are not significant. Therefore, this is not significant, this is not significant, this is not significant. This is going to be the first digit that is significant. Therefore, we'll start counting from here. Our first significant digit and our second significant digit. As you can see, the 0 in the middle will be counted as a significant figure. The only one that isn't counted is the one that is leading, the ones at the start. Therefore, 0 is my stop digit. Then I draw my door next to it and I see the number. Because it is less than 5, 0 will remain 0. And so rounding this off to 2 significant figures will look like this, 0.0040. These 3 are not significant. These 2 are significant. Finally, we go on to estimating answers. And to estimate a calculation, we usually round off to 1 significant figure so that it is easy to do the calculation in your head. For example, if you're given a question like 87.4 times 1.1 divided by 0.48. This looks very hard at first sight to do it on your own, and you probably need a calculator to get the exact answer. But we can get an answer that is close enough to it. How? By rounding off each number into 1 significant figure. 87.4 to 1 significant figure would be what? The first significant figure is 8. Draw my door, look at the number next door. It's 5 or more. Therefore, I will round this up and I will get 90 from it. In this case, as you can see, the trailing 0 is not counted as a significant figure, and the digit 9 is my only significant figure in my approximation. So 87.4 will be rounded off to 90. When I look at 1.1, my first significant figure is 1. I'll draw my door, look at the number next door. It's less than 5, therefore 1 will remain 1. Therefore, this rounded off to one significant figure is just 1. Then we look at 0.48. The first significant figure is this right here, the number 4, because 0 is a leading 0, which does not count as a significant figure. 4 is my stop digit. Draw my door, look at the number next door. It's more than 5. And therefore, we will round up. So 0.48 will become 0.5. So this question right here, 87.4 times 1.1 divided by 0.48, can actually be estimated to 90 times 1 divided by 0.5. And this is a much nicer calculation to deal with. It's easier to do. This is just 90 divided by 0.5. And if we're doing that, that's just 90 divided by 1 over 2, which is just equal to 90 times 2 over 1, which just gives you 180 as your answer. So this is not exactly what 87.4 times 1.1 over 0.48 is, but it's an approximation of it. And if you check 87.4 times 1.1 divided by 0.48 is equal to 200.29 roughly, if you find the exact value from your calculator, which is close enough to our approximation of 180.